All right, in this video, we're continuing our conversation of standard enthalpies, but we're going to look at standard enthalpy of formations. Um, and so these are things that we look up in a table, and the standard enthalpy for formation for an element in its pure state is going to be 0. And then for a compound, it's going to be the sum of whatever elements comprise it. Um, so we have this really handy equation for the standard enthalpy of a reaction. It's going to be equal to the sum of the enthalpies of formation of its products minus the sum of the enthalpy of formation for its reactants. And note that we multiply that formation of either a reactant or product by the number of moles we have, N, which is that mole ratio. Remember that little F tells us that this is a heat of formation. And any element in its standard state will be 0. So, for example, the enthalpy of formation for ethanol is going to be negative 277.3 kilojoules per mole. And that's going to be by combining carbon, hydrogen, and oxygen, which would all be in their elemental state and so have an enthalpy of formation of 0. So let's take a look at this in more detail. First, here is a chart. Sorry, here's a table of different standard enthalpies of formation for different compounds. You'll notice things like bromine liquid is in its pure elemental state, so it has enthalpy of formation of 0. But something like methanol has an enthalpy of formation of negative 238.6. And this is in kilojoules per mole. So we can use this table to fill out that equation we looked at that shows that for a reaction, we take the enthalpies of formation, the sum of the products, and minus the sum of the reactants. So here's an example of this. If we want to look at sulfur trioxide reacting to form sulfur dioxide and half a molecule of oxygen, we would be able to take the sum of the reactants, or sorry, sum of the products right here, and subtract from it the sum of the reactants enthalpies of formation right here. And these values are coming from our table that we just showed. So we can see that for that sulfur dioxide enthalpy of formation, we can come and find it here. Here is our sulfur dioxide, negative 296.8. And so we put in that 296.8 or 297 right here. For our oxygen, because that's in its elemental state, it'll be 0. And so for our sulfur trioxide, we can come and look up that right here. It's right underneath our sulfur dioxide. So it's negative 395.7. And so that value gets plugged in right here. Remember, it's always products minus reactants, and we multiply by our coefficients. And so we have a coefficient of 1 for both our sulfur dioxide and sulfur trioxide, but we have a coefficient of 1/2 for our oxygen. And so that oxygen enthalpy of formation is multiplied by that coefficient of 1/2, which is still just 0. And then we take the sum, and we end up with an enthalpy of reaction that's 99 kilojoules.